Okay, in this example, we have a game called Mastermind, which is a real game. It's a game where you create a code using different colored pegs. The opponent's job is to guess not only the colored pegs you're using, but also the correct order. We'll play a simplified version of this to better understand permutations, or the multiplication principle. Uh, and then we'll use this example again later when we actually talk about permutations as well as combinations. Now the colors that I have for the colored pegs are pink, yellow, orange, green, blue, and purple. So I'm going to put them up right now. And so you can see that we have 6 colored pegs. Now what's going to happen is the code maker will create a code using 3 pegs. In other words, they're going to have like a little wall here, and then behind this wall you're going to select 3 of these pegs. So one example would look like this. Now the code breaker, your opponent, cannot see these 3 pegs. They're trying to figure out the code, not only the colors, but also the order in which they show up. So in this case, this is one particular code right here. An example of another code would be, notice that they're the same colors, but the order now is different, so this counts as a separate code. And then just to give you an example of one more code, would be one like this, where this is, I think, yellow, orange, and green. So again, 3 pegs, different colors now, and again, the order does matter. So now, as the code breaker, you would like to know how many ways, or basically how many arrangements, or how many codes can you make using these 6 pegs, and you're picking 3 of them to make your code. How many ways can you do that? Because you would like to know, if you were to just to randomly guess, what are the chances that you get it right? All right, so here's what we're going to do. We're going to do something that I'd like to call the task method, in that each task, picking a peg, has a certain number of ways that can be completed. So let's put these lines here. Now these lines represent your tasks. Okay, so we have your first peg, your second peg, and again the order matters. So this would be your third peg. And I want to know how many ways can you complete your first task. So right now, as the code maker, you have how many available? And we have 6 pegs available. All right, so we have 6. All right, so we're going to put a 6 here. All right, so now let's move on to the second task. How many do we have available? Well, here, let's take a look at this. Let's say, as the code maker, you chose the pink one to put down. Now that you've put the pink one down, how many do you have available for your second pick? So your second task looks like we only have 5 available. So the number of ways you can complete the second task would be 5 ways. So we're going to put a 5 here. And then let's say that was I think this is blue right here, so let's choose this peg. And finally, going on to the third task, we have how many available now to choose, and we have 4 available. Okay, so we're going to put a 4 down. By the way, I erased this, but for this one we had 6 available to choose from. Now we had 5. Now we have 4. So let's go ahead and pick. Here, let me move these. So let's throw them up here. All right, so let's pick, I don't know, let's say the yellow one. Let's put that down there. And we had 4 ways of doing this now because we had 4 available pegs. Now since these are our 3 tasks, and the first task can be done 6 ways, the second task 5 ways, and the third task 4 ways, the method, or the multiplication principle, says that to find out how many ways you can do the tasks, or in this case, the number of arrangements, you would multiply all the number of ways you can complete each task together. So that would be 6 times 5 times 4, which would equal 120 ways. So as the code maker, you have 120 codes you can make, which isn't which isn't that bad. As the code maker, you have 120 possibilities that you'll have to figure out using the hints that the code maker gives you. Okay, so let's change this up a little bit. So we got our 6 original pegs, and now the code maker doesn't have to just choose or pick 3, but let's say that now they can use all 6. So let's say so let's go back up here to guess. Okay, so the code maker will create a code using 3 pegs. Let's now say they can use all, so using all pegs. So how many ways can we do this? All right, well, using the task method, okay, write a line that represents each task. And since we can, when we say that they have to use all pegs, it means their code is 6 pegs long, each line representing a task. All right, so how many ways can they pick their first peg? So the first task, how many available pegs do they have? And they have 6 available pegs. So let's put 6 down. All right, now that you've removed one of the pegs, you're 1 down. So how many do you have available for your second? And you only have 5. All right, so let's, again, as an example, let's say you've picked this purple one over here. So you've taken this peg out. Let's put it over here. So now we have, notice we only have 5 available pegs. So let's take out the pink one. Moving on to the third task, which is your third peg, we'll notice how many we have available now. That would be 4. All right, so let's say that's the green peg. For the fourth task, all right, how many pegs do we have available? That would be 3. So hopefully you can see where this is going. All right, so let's throw that one down here. And then for the fifth peg, we only have 2 available. So let's say that that was the orange one. So let's pick that one. And finally, for your last task, for the last peg, how many are available? Well, you've already picked the previous 5, or you've used 5 already. So we only got 1 left. So we only got 1 peg. 1 peg. And let's put that down there now. All right, so the multiplication principle says, once you've figured out how many ways you can do each task, multiply all of those together to get the number of ways you can do all the tasks. So the number of arrangements, would be multiply all those numbers together. 6 times 5, 4, 3, 2, and 1, and that equals 720 ways. So now, if you were playing this game where you were able to use all pegs as the code breaker, there's 720 possible codes. When we only picked 3 pegs, there was only, I think, 120. So the more pegs you use, the harder the code, and that makes sense. You know, everybody's made a password like email. The more characters you use, the harder it is to break that password because there's more possibilities. Okay, so hopefully this is a decent introduction to the multiplication principle. I'm going to call this the task method, and where you would write out a line representing each task, and then on top of that line, write out how many ways you can complete that task. So to figure out the number of ways you can do all of the tasks, in this case arranging all of these pegs, you would multiply all those numbers together.